Oh, here we go, boys and girls. Hope you're doing all right. Hope everything's going well. I'm filming this on our second snow day, but it should be Monday or Tuesday the next week. I am out of town, Palm Springs. Maybe you've heard of it. Maybe you've heard of it. But I am probably loving life. Got a little video for you here. Got a little video for you here. Um, we're just gonna keep learning stuff. So let's jump into it. So we're going to do two sections today. I know that seems like a lot. And there might be some stuff that I don't know that you already know, but we're going to kind of roll through. There's definitely going to be some times where you're going to want to pause and write some notes down because we're going to go through like a fair number of theorems here. But yeah, it should be good. Oh, I guess I don't want to do it like that. Maybe that's better. Now you can see everything. All right, let's do it like that, and then I can write easier. So here's the definition of a parallelogram. So last week and the week before the crazy snow, we learned all about different types of polygons, concave, convex, angle sums. We did all that good stuff. It's all good stuff to know. The rest of this chapter is we're working on quadrilaterals. Quadrilaterals have four sides, and we're going to talk about different quadrilaterals. Okay, that's the goal of the rest of the chapter. We're going to start with parallelograms. So 6.2 and 6.3 are on parallelograms. Okay. So here's the definition. A parallelogram is a quadrilateral whose opposite sides are parallel. Pretty straightforward. We can see this in the picture here. Opposite sides are parallel. Okay. That's the definition. Now there's a bunch of other cool properties that parallelograms have. A simple shape like this has a bunch of cool properties. So we're just going to jump. Normally, I'd have you brainstorm some and we'd chat it up, but hey, this is recorded. So now we're just going to go through a bunch of theorems. I'll read them, maybe explain a little extra, but then I'm just going to move on to the next. So if you want to keep writing, I would pause it and write these down. These are going to be super important for us for the rest of the chapter. I'm not kidding. Like, this is like super important because everything we're going to have more parallelograms, right? A square is a parallelogram, a rectangle is a parallelogram, a rhombus is a parallelogram. So we're going to use all this stuff a lot. Okay, the first one says, and they're just numbered. Theorem 6.3, properties of parallelograms. You're not going to have to remember. If you use this in a proof, you could just say property of parallelogram, parallelogram theorem. Don't have to memorize these numbers, okay? So we know opposite sides are parallel, and 6.3 also tells us that opposite sides are congruent. So in a parallelogram, we have the opposite sides are congruent and parallel, okay? Which again makes these super interesting because they got a lot that can happen. That's theorem number one. The next theorem. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So we got opposite sides are congruent, we got opposite sides are parallel, now we got opposite angles are congruent. Okay? That's a lot here. There's a lot we can learn about parallelograms. Theorem number three. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay? So we know same side interior angles going both ways add up to 180. So these ones going this way are going to add up to 180, and these ones going this way are going to add up to 180. Okay, so anything that's on the same side in a parallelogram is going to add up to 180. And that's just same side interior angles because we got two sets of parallel lines. All right, we're cruising. So theorem 6.6 says if a parallelogram has one right angle, then it has four right angles. Okay, so in this case, if we know there's one, then they're all right. We can get that from the previous two uh, parallelogram theorems. Okay, and then they're all right angles. And that means now we're either dealing with a square or a rectangle. So if you know one of them is a right angle, all of them have to be, and then you know at that point it's a square or a rectangle. If you know it's a parallelogram, it's got to be a parallelogram too. Okay, 6.7 says if a quadrilateral is a parallelogram, then its diagonals bisect each other. And they didn't show this well on Z chart. But if we know it's a parallelogram, then we know that these diagonals bisect each other. Should probably do three slashes to make it clear it's not the same as the sides. These diagonals bisect each other. Then these diagonals also bisect each other. So we get these diagonals of the parallelograms are splitting each other in half. Now, AP and BP aren't necessarily congruent. So these two right here are not necessarily congruent. These two down here are not necessarily congruent. Okay? Last one. Here we go. And then we'll use these and do some practice. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. Okay? There's a whole proof of this, but right, we know opposite sides are congruent. And then we also have this side in the middle that's reflexive. So you can already see we just proved side, side, side. There's a bunch of other ways you could prove that these two triangles are congruent. But if you just have one diagonal in there, then you get that these triangles are congruent. It splits it in half, makes them even. So that makes a lot of sense, right? Nice. Let's try some problems. In parallelogram ABCD, suppose angle A is 55, AB is 2.5 feet, and BC is 1 foot. So if we know A up here is 55, then we know the opposite angle here, C, is also 55. And then we know B and D are going to be equal, and they're going to be supplementary with 55. So what is that? A 125? Is that right? Yeah. 125 for these guys. I don't know. That was a weird little arrow. Sorry. 125. And then the opposite sides are going to be congruent. So AB, let's change colors. Changing the colors. If AB is 2.5, then DC is 2.5. Okay. So opposite sides are also congruent. This is 1 foot. This is 1 foot. Okay. Really quite simple. So we could do it with algebra too, right? So we could set up a couple different equations. Opposite sides are congruent, so you could set this one up as 5y equals y plus 8. Just set those two equal because you know they're congruent. Boom. And then for the x's, we know that these have to add up to 180. So we can just add them together and add them up to 180. Ready, Rue? And then diagonals bisect each other. These are congruent. So again, you could just set these equal. Not too bad. Not too shabby. We can skip all those. So we're gonna get back into a few proofs here. This one's not that bad. But yeah, let's do it. Look at that straight line. Whoa, two in a row. It's hard for me to write, so I'm not going to write out the given, but you should because you should. But it's hard for me to write with the mouse. So we know A, B, C, H, and D, C, G, F are parallelograms. And we want to prove A and F are congruent. Okay? Well, I know that A and C are congruent because opposite angles are congruent in parallelograms. So I'm going to say angle A is congruent to angle C, right? And you could call that prop of parallelogram. I don't know if you want to write all that out. Prop of parallelogram. I think in the past, I think in the past we've also called that pop like this with a little O and two big P's, properties of parallelograms. So if you want to call it pop, you could call it pop kid. Call it a little popper. And could we do the same thing going the other way? Yeah, we could. So we could say angle C and angle F are congruent. Also by pop. And now look, we have two things that are congruent to angle C, so they have to be congruent to each other. Transitive property. This is a nice little proof. Whoops, that's an F. So transitive, and there you go. That's your proof. You could also probably have used vertical angles somehow. Probably also have used vertical angles there. Actually, maybe you need to. Yeah, I think I missed a step because I just assumed angle C was congruent to angle C, but these are actually different angles. Yep. So before this, we needed to say, sorry, that was a mistake. Yeah, I'm trying to get a different arrow. Before this, we needed to say, we probably should have named it angle BCH is congruent to angle DCG, and we needed to say vertical angles there. Then we could have done it. Okay, so an extra step in there. That's my bad. Sorry, I just assumed. I mean, these are equal by vertical, and I just kind of named them the same, but I shouldn't have done that. Okay, that was it. So that was 6.2. All right, that was 6.2. Now we're going to do 6.3. Okay, now 6.3, we're going in the opposite direction. 6.3, we're not going to know if these are parallelograms, and we're going to want to show that they're parallelograms. You know what I mean? You know what I mean. Okay, so if we know a quadrilateral has each pair of opposite sides parallel, then we know it's a parallelogram by definition. So if we got a four-sided shape and we can show that opposite sides, whoops, that's congruent. Doing such a good job today. So if we do this and we can show that these are parallel, then we know for sure it's a parallelogram, but there's other ways to prove it, okay? There's other ways to prove something's a parallelogram or to just show it if we're not even doing a proof. We're going to have that. We're going to do a little coordinate geometry today, guys. A little coordinate geometry. I'll just show you all these. So we could use the parallel lines. If we're able to show opposite sides are congruent, that also works. If we're able to show opposite angles are congruent, that also means it's a parallelogram. If the diagonals bisect each other, then we know it's a parallelogram. And lastly, this one's kind of fun. If you can show one pair of sides is both congruent and parallel, then you know it's a parallelogram. So even if you didn't want to mess around with doing both pairs of sides, you could just pick one pair and show they're congruent and parallel. And this is all here in your book. Don't write these down. It's just these that you want to write down because this is just a little nicer organized. But you can look at these pictures if you want. But this goes, you can see that these are like converses of our 4.2 theorems. Okay, so let's just look at some examples. Are these parallelograms? How do we know if we know yes, no, maybe so? So in this case, we have these sides are congruent. They're both 14 inches. And what do you recognize about these? Oh, alternate, or sorry, same side interior angles converse? Yeah, same side interior angles converse. So these have to be parallel. And so this fits with number 4. Both sides are congruent and parallel. So this is a parallelogram. okay, by our number four test. Number four test. You don't have to remember the numbers. It's fine. What about this one? We got one pair of sides are congruent and one pair of angles are congruent, but we can't do anything else. We need something else here on this middle one. We'd need like parallel lines, or we need another angle here or here. We just need more info. So this one we'd say no, cannot prove it. But this one, yes, right? You can just easily see both sets of opposite sides are congruent. And so then it has to be parallelogram. That's rule number one. Yeah, rule number one. So you see, this isn't too bad yet. Skip, I think. Okay, one more thing. It's kind of long, so let's do it. This is what we've been leading up to. Coordinate geometry. Coordinate geometry. Okay. Um, so first thing you're going to want to do is you're going to want to graph this. So we got to get up our old Cartesian coordinate plane. Oh boy, here we go. So do make a little graph in your notes with me. What are we going to? 8? Was that 7? 1, 2, 3, 4. No, that was 8. We're going to go to 8. Sorry, that line's a little slanted. Ignore it. Okay, so we went 8 in each direction. Now we're going to graph the points. You want to do this to make sure you know you're picking the right sides. We want to do this so we know we're picking the right side. So K, remember go X first. So over 2, up 3 gives us K. L is 8 and then up 4. Should probably also write the points. So we got 8, 4, we got 2, 3, and then we got 7 here, and then -2. So that's M7, -2. So we want to be able to see which sides are matched up here, and then we got 1, -3. That's N. Okay, and there's our parallelogram. And we could draw a little dotted line to just see how it looks. Actually, we don't know if it's a parallelogram. We're trying to determine that. My picture is really bad, so it's hard to know. But also your graph won't count. If you're just like, yeah, it's a parallelogram, not going to count. So you need to actually go show that this is a parallelogram. Now there's two ways you can do it. Anybody know? What do you think? One way is you could use the distance formula. So option one is use distance formula. And we've done a lot with the old distance formula, so you know it pretty well. So if that helps, then you could use the distance formula and show, sorry, my writing's so bad here, show opposite sides are congruent. Okay, so you'd have to do it 4 times. Okay, you're going to do this, you'd have to do it 4 times. Four times, okay? So you got to do it 4 times to show that that works. So if you're more comfortable with the distance formula, use the distance formula. What's the other way we could do it? We could show opposite sides are parallel. Yes, we could show opposite sides are parallel. And what would we use to do that? Yeah, the slope. Okay. So we could use slope 4 times to show opposite sides are parallel. Those are the two easiest ways. You could try to find something with the angles, but it gets a little more complicated. We're going to do that more later when we do something similar with rectangles and squares. Sorry, some of this writing is so bad. So bad. But there you go. So I'm going to do it with slope. I think we've done a lot of distance formula. So if you're comfortable with distance, feel free and do that. But I'm going to do it with slope just to maybe do something a little different. And I think it's maybe a little easier. I don't know. But again, I would list them out. So we're going to do KL and NM first and compare those. And those need to be the same. They got to be parallel. So they got to have the same slope. If they don't, you could just stop there and say it's not a parallelogram. Okay. Remember slope. It's y2 minus y1 over x2 minus x1. Okay, and so we're going to do 4 minus 3 over 8 minus 2 for KL. So that gives us 1/6. So that's the slope of KL. And M, we're going to do -2 minus a -3 becomes +3. I'm just getting the numbers from up here on my chart. And then 7 minus 1. So that also becomes 1/6. So you can see these are equal. So we know those two are parallel. We could draw that on the big board. These two then are parallel. So we got one set of parallel sides. You could also, actually, option three is you could do one. No. Yeah, you could do that. Option three would pick one side, like one pair of sides, and do both slope and distance if you wanted to mix it up. So option three would be we could show KL and NM were both parallel and congruent. And you could do slope twice and distance formula twice. So put them together. And that might be more fun or interesting or less boring. I don't know. But let's continue with what I was doing. Let's do a little purple. So now we're going to do KN and LM. Okay, so KN, we're going to get 3 plus 3 because it's minus a negative over, sorry, I did 3 plus, so I'm going to do 2 minus 1. Yeah, which makes sense. So we're going to get 6. And then LM, same idea. We're going to do 4 plus 2 over 8 minus 7. And that gives us 2 over, sorry, 2. That gives us 6 over 1 as well, which is 6. Sorry, I should have probably done that up here. And so those are also parallel. So these guys are parallel as well, so we know it's a parallelogram. So it's a little tedious. I understand it's a little tedious, but it's a good skill to be able to do it. We're working on our algebra, we're working on our graphing. I think it's important for us to continue working on those skills, and it's not that bad once we get it going. Do slope 4 times, or do distance 4 times, or do 2 slopes, 2 distance. So you kind of get to pick which one of these you like. Doesn't matter to me. Feel free to use distance. We've done it a lot. Feel free to do one of each to keep it interesting. So I think that's it. I think that's probably like a 20-minute movie here. So hopefully that gave you something, and you were pausing it to write some of that stuff down. So I bet that took you a decent amount of time. I'll see you when you come back and we can talk more about the future. I don't think we'll have a quiz this week because the snow. So just keep working on this and great to see you, and we'll see you soon.